Viewers to my YouTube channel today. In today's class, we are going to be looking at a very interesting topic in physics called simple DC circuits. Your simple DC circuit is also referred to as current electricity. Okay, now if you are a student preparing for JAMB exam, or you are preparing for WAEC exam or other related external exam, do well to subscribe to this channel for our contents, and also make sure you on your notification bell so that whenever we post video you will be notified. Now let's dive into what we have for today. We are going to begin with what we refer to as electricity. What is electricity? Now, electricity simply means the flow of current through a metallic conductor. Yes, the flow of current through a metallic conductor is referred to as electricity. Okay, now when we talk about conductors, what do we mean? What's the meaning of the word conductors? Like I said, electricity is the flow of current through a metallic conductor. What is a conductor? A conductor is a material of low resistance. Take note of that. A conductor is a what? A material of low resistance. Yes, that what? That allows currents to do what? To pass through them. I repeat again. A conductor is a material of low resistance that allows currents to do what? To pass through them. Now, what do I mean? The word resistance means the opposition offered to the flow of current. So, for a material to be called a conductor, that material must have low resistance. So, we'll simply say that conductors are material of low resistance. Now, because of the fact that they have low resistance, current can easily pass through what? A conductor. Do you understand? Then I'll give you a few examples of a conductor. All metals are conductor. All metals are conductor, e.g. sodium metal, aluminium metal, zinc metal, mercury metal, silver metal, etc. All of these are referred to as what? Conductors. Okay, now if all of these are conductors, now including your what? Your graphite. Graphite is a good conductor of what? Electricity. And including your waiting now, you have all metals, which is this. You have graphite and you have what? Alloys. All alloys are good conductors of what? Electricity. So take your pen and your book. Note it that conductors are material of low resistance that allow current to pass through them. And these conductors are metals. It includes graphite. Graphite is an allotrope of carbon. Then it include waiting alloy. So take note of that. Now we'll dive into something else which we refer to as insulators. What are insulators? Insulators are material, in the other hand, of high resistance. Don't forget I told you conductors are material of low resistance. Okay, now insulators are materials of high resistance that what? Do not allow current to pass through them. Do not allow current to pass through them. Current to pass through them. To pass through them. Take note of that. So, what do we refer to as insulator? An example of an insulator is your wood, e.g. your wood. An example of insulator is your glass. Glass is an insulator, including waiting, including plastics. They are what? Insulators. So understand the fact that conductors are materials of low resistance that allow current to pass through them, and include all metals. It includes graphite and it includes alloys. Alloys are material containing two or more metals. An example of an alloy is what we refer to as bronze. Yes. So alloys are a combination of two or more metals. Okay. So all of these are conductors, while these one are what? Insulator. Do you understand? Now understand the fact that conductors, materials are called conductors because they do what? They have free valence or mobile waiting electrons. Take note of that. So we can conclude that the carrier of current in conductors are the free valence or mobile electrons. Yes, think of that. So a material is called a conductor because it has free valence or mobile waiting electrons. Then a material is called an insulator because it do not have free valence or mobile electrons. For instance, if you combine the allotrope of carbon, we have diamond and graphite. Graphite is a good conductor. Why? Because it has free valence or mobile electron. But diamond is an insulator because it does not have free valence or mobile electrons. So understand these two terms of what we call the conductor and what? An insulator. Now, as we dive into this simple DC circuit and current entity, it will be important for you to understand a basic law. Yeah, the laws is the law that governs the calculation of questions involving simple DC circuit. And that basic law is known as Ohm's law. So take your pen. Let's begin. What is Ohm's law? Ohm's law. Now listen, Ohm's law states that the current flowing through a metallic conductor is directly proportional to the potential difference across its ends, provided that the temperature and every other physical parameters are kept constant. Yes, that's Ohm's law. So before you can dive into questions involving simple DC circuit, you must first understand your Ohm's law. So according to Ohm's law, we have it that V is equals to what? I arrow. Take note of that. This is what your Ohm's law says. Now, we are waiting now where V is known as what? Voltage. We either call it voltage or we call it potential difference. Potential difference. Take note of that. Potential difference is measured in what? Volt. I is known as the current. Current is measured in what? In ampere. It should be noted, this is your current. Arrow is known as what? The resistance of the weighting of the resistor. And this is measured in ohms. Take note of that. The unit, the symbol for ohms is like this. This is the symbol for ohms. So according to Ohm's law, V is equals to I arrow. Now, take it carefully. Listen. If you have V equals to I arrow and we decide to make our arrow subject formula, we therefore divide both sides by weighting arrow. So if you divide here by I, divide here by I to make arrow subject formula, this cancel this, arrow will now be equals to V over what? Over I. What did I say arrow is? Arrow is referred to as the resistance of the resistor. Now, as the resistance of the resistor, I told you that the unit is what? Ohms. But the derived unit from this formula, where you have volts and ampere, is what? Is volt per ampere. So it means that your resistance of the resistor can be measured in ohms or weighting volt per ampere. Now, what we are going to do, we are going to look at a graph that illustrates the relationship between voltage and current. Do you understand? Yes. If the voltage is directly proportional to the current, while the resistance remains constant, it simply means that if the voltage increase, the what? The current will increase for a simple DC circuit. Now let's draw the graph that illustrates your what? Your Ohm's law. Let's do that quickly. Now, take a look at this. If I have a graphical illustration of Ohm's law, if I have a graph of voltage or PD means potential difference. If I have a graph of volts against current, how would the graph look like? Now take a look at this. What is the relationship between voltage and weighting current? The formula states that V is equals to I arrow. So the relationship between voltage and current, where arrow is known as our constant, which is the resistance, is a direct relationship, meaning if the voltage increase, the current will what? Will increase. Do you understand? So that's why we have it like this. Yes. This indicates that the voltage and the current are increasing at the same time, or they are reducing at the same time for a direct relationship. Now understand this, class. Look at this. Look at this. If I have V equals to I arrow, it means that my voltage will be in this place while the current will be in this place. So if you watch very well, the slope of this graph, don't forget that slope means change in y over weighting, change in x. And in the y-axis, what we have is our what? Volt. While in the x-axis, what we have is the what? Current. So the slope of this graph, the slope is change in the y-axis, which is volt, over change in the x-axis, which is what? Current. So if you watch very well, your resistance is volt over current. So that simply means that the slope of volt against resistance, the slope is the same, the slope of volt against current in this graph is the same as the resistance. So we can determine the resistance of the resistor, which is in ohm, by simply looking for the change in the voltage to the change in the weighting current. Okay, do you understand? Now we are going to dive into what we call connecting your resistance in series and in what? In parallel. Let's do that quickly. Now let's look at resistors in series. Now, two or more resistors are said to be in series if they are connected end to end, as you can see in the diagram. Now, this one is the resistance of the resistor 1, R1. This one is R2, while this one is R3. So these resistors are in what? Series. Why? They are connected end to what? To end. Should be the same. Now watch this. Now if I connect a source, a DC source, like a battery, to these three resistors, let's see the connection. It goes this way. This is a DC source. Let's see the connection this way. This is our voltage. Okay, now this is our voltage. Now take a look at this. If the current flows this way, this is the positive terminal, negative terminal, positive terminal, negative terminal. So the current flows this way and gets into this resistor. You discover something, that the current that enter this resistor will leave this place, come here and enter this resistor. The one that enters here leave here and enters here. So if you watch very well, the current remains the same. That's why we'll label the current here as what? I. We'll label the current here as what? I. We'll label the current here as what? I. So it should be noted that for a circuit in series, for a circuit or resistors in series, for a circuit or resistors in series, the current remains the same. The current remains the same. That is to say, the current is constant. So avoid using I1, I2, I3 for a circuit in what? In series. See the way I do them. I here. Why? Because the resistors are connected end to end. It should be what? Noted. Note it. For a resistors or circuit in series, the current remains what? The same, remains constant. Now, look at this. This is what will happen. The voltage here, and the voltage here will certainly not remain the same. So we observe that the applied voltage here is known as your what? Your V3. See it? V3, like this. Okay? The applied voltage here is known as your what? Your V2, like this. Shade again. It's called V2 because you have arrow 2. It's called V3 because you have arrow 3. Your applied voltage here is called your V1. So we have voltage in the first resistor, voltage in the second resistor, and voltage in the third resistor. So you discover something, that the voltage are not the same. That's why I numbered it. Okay? So you still understand that for a circuit in series, there is a voltage drop. There is a voltage drop across the resistors, across the what? The resistors. There is a voltage drop across the resistors. So that is why the total applied voltage, which is here, V total, the total applied voltage is V1 plus V2 plus V3 as the case may be. So this is the total voltage. But for current, we don't have I1, I2 or I3, it's just I, because the current remains what? The same. Now, understand, say, for Ohm's law, our V is equals to 1, I arrow. Abi now? So if V is I arrow, and listen, our V1 will give us I arrow 1. That's how it will look like. So this V total now, wey you dey see here, this V total, because V is equals to I arrow, your V total will be what? I arrow total. Shey you dey get? Yes. See am. I'm not bringing the current because the circuit is in what? Series. Statement of that. So this one now will be I arrow 1. This one will be waiting. I arrow 2. This one will be waiting. I arrow 3. Shey you dey get? Yes. So now, this guy now, that is I arrow total. What is common between all of these guys that you see here? What's common? I. So I is the same. Because of that, bring your I come out. Here will be remaining arrow 1. Here will be remaining waiting, arrow 2. Here will be remaining waiting, arrow 3. So if you observe very well, your I can cancel your I. So arrow total will be equals to R1 plus what? R2 plus what? Arrow 3, as the case may be. So we can have continuously. Now, wetin be this formula? This formula is what? Used to do what? To calculate the what? The total resistance. Total resistance or net resistance. In what? In series. It should be noted. So to calculate for 2 or more resistors in series, R total is equals to R1 plus R2 plus waiting R3. Do you understand? Get this. For a circuit in series, the current remains the same. For a circuit in parallel, there is a voltage drop across the resistors. So the voltage is not the same. If you define the voltage wey dey here is V1 equal to I arrow 1, voltage here V2 equal to I arrow 2, voltage here V3 equal to I arrow 3. This must be what? Noted. Now more run go resistors in what? In parallel. Let's do that quickly. Now let's take two or more resistors connected in parallel. For 2 or more resistors connected in parallel, how will you draw the diagram? Let me show you. Look at this. You have your conductor coming between 3 resistors. See it here. Okay. Watch carefully. Do you get? So 2 or more resistors are said to be in parallel if they are connected side by side. If they are connected side by side. See? So this connection is in parallel. The reason is because the resistors are connected side by side. Do you get? So this one is called R1. This is R2 and this is R3. Watch carefully. Now, if I connect a PD, a voltage to these 3 guys, now, this is my voltage. If I connect my voltage, minus plus, okay, this is negative, this is the positive terminal, and this is my voltage. And then the current comes this way. Watch carefully. Watch carefully. When the current gets to this point now, this point, the current has no option but to divide. There will be a division of current. One will come this way, one goes here, and one comes here. That's why for a circuit in parallel, the current varies. Okay? So it should be noted that for 2 or more resistors in parallel, what will happen? Talk to me. The current varies. So the current will not be the same. The current varies. So what do we observe? The total current coming from here now is called the I total current. Okay? Now this current becomes divided between the resistors. So what you have here is called I1. See it, I1. The one here is called I2. The one here is called what? I3. But what the current from here is known as the total waiting current. So for a two or more resistors in parallel, the current varies. So the total current now is the current coming from the battery. Do you understand? So it's equals to what? I1 plus weighting, I2 plus weighting, I3. It can be more than 3 currents when you have more than 3 resistors in parallel. So understand this now. The I total is I1 plus I2 plus weighting, I3. Understand that. But we discover something. Watch this carefully. Remember that from Ohm's law, V is equals to what? I arrow. Abi now? Okay. Make arrows isolate formula now. You have divide both side by weighting by arrow. So this cancel this. I is V over what? Arrow. So this is the expression for the current. Watch carefully. I total is I1 plus I2 plus I3. Okay. Now you must still note something, that I did not number the voltage. Yes. So it means that for a circuit in parallel, the voltage remains the same. The voltage remains the same. Remember that voltage can also be called potential difference. So let me put PD here. The voltage remains the same. So no need to number the voltage. There's nothing like V total. There's nothing like V1, V2, V3 for a circuit in parallel. You must take note of this before we begin to solve questions involving circuits, resistors in series and parallel. Make sure you note this. Now, this I total now is equals to V over arrow. So for our I total, we have V over arrow total. Shall you get? Yes. I did not put V total. Why? Because the voltage is what? The same. No need. So in this place now, you have V over arrow 1. Because you have I1, you have arrow 1. In this place now, you have V over arrow 2. Here now, you have V over arrow 3. Should be this here. Now, understand this. In mathematics, I can simply say V bracket 1 over arrow total. Why? Knowing fully well that if I open this bracket, I will have V over arrow total. We use it to multiply the numerator only, not the denominator. So you have V over arrow total. So that means in this place now, you discover that what is common to all of them is that their V is constant. So if I bring my V out, I will have 1 over arrow 1 plus 1 over arrow 2 plus weighting 1 over arrow 3. Shall you get? Why? Because if I use V to open the bracket now, if I use V to times, I will have this. V times this, I will have this. V times this, I will have this. So the voltage is the same for a circuit in parallel. So what do we do finally? Watch this. I can use this volt to cancel this volt, so that 1 over R total is equals to 1 over R1, 1 over arrow 2 plus 1 over arrow 3. Okay, so this formula is used to do what? Calculate for, okay, 2 or more resistors in parallel, 2 or more resistors in parallel, 2 or more resistors in weighting in parallel. It should be noted. Why for series, you don't have these reciprocals. You just have arrow total equals to arrow 1 plus arrow 2 plus arrow 3. Please note this. Take note of this. It's very important. Then there is this important formula too. This shortcut. Listen, if you have 2 resistors in parallel only, okay, for R1 and R2 in parallel only, if you have only 2 resistors that are connected in parallel, you don't have to stress yourself using this formula. All you have to do is simply do this. R total is known as what? R1 times R2 over R1 plus R2. So whenever you have 2 resistors connected in parallel, instead of using this formula and start looking for HCl, it is better to use this one, product over sum. This R1 times R2 signifies product, while this one signifies weighting, sum. So this must be what? Noted. Now, if today is your first time of coming across my YouTube channel, please don't forget to subscribe and on your notification bell so that we come and post video online again to get across to you. Thank you very much. I'll see you in my next video.